Hello, welcome to 50green.com. This is Otis Bradley, and today we are going to talk about container homes. Every time I do an article on the blog about container homes, I get lots of response. People are fascinated by these container modules and their use for homes. There's all kinds of innovative techniques, some which are possible and practical, and others which are just pure fantasy. In today's video, we've got Jeeps and containers. What's in container? I'm going to show you example buildings. I'm going to show you how to design, and I'm going to show you a bunch of interesting container homes as well. Jeeps and containers. All right. If you're about my age and you read comic books, you probably saw this. The $50 Jeep. It was in the back of every comic book, I think. The idea was, and it actually came in a container, you could buy a Jeep, an Army Jeep, one of these really cool old Army Jeeps for $50. But when you sent away for the thing, I think it sent you back a little piece of paper that told you how to find government auctions, because most of these Jeeps, this is Okinawa after World War II, they were buried, they were just dumped, and very few of them actually got into civilian hands, but some did. And I kind of feel like containers are a little bit like this too. I mean, they're the ultimate in practicality, these containers. There certainly are zillions of them. I think there are approximately 18 million of these things worldwide estimated. But they're just boxes, and converting them to homes takes quite a bit of effort. You can see here how they're all stacked up horizontally and vertically. We're going to talk about what makes sense in terms of turning these into homes and what doesn't. But first, a couple fun facts. As I said, 18 million of these containers worldwide. Typically 5 to 6 million in transit. So virtually the world survives on these things. Everything that gets transported is put in a container and shipped across sea. And then the reason for these containers is you can easily pop them on rail or on trucks to distribute locally. And sometimes, depending on world trade, there's more in the United States than there are in China, as is the current situation, or any of the other ports in the world. There is a constant flow of these things. And interestingly enough, I found out that they estimate they lose about 2% of these things a year. So by some counts, there are some 10,000 of these things floating around in the ocean. So if you're a trans-ocean traveler, you might want to get a radar gun or something like that, see if you can spot them. They come in all different shapes and styles. As you can see here, the top of this one doesn't line up with the top of this one. That's because this is a high cube. These are longer than the standard. These are 40 footers. The typical one is a 20 footer, and you can see certain shipping companies have their own boxes. This is the China shipping line, and obviously there are humongous ships traveling the globe with these containers on them. Everything from what they call, there's like 6 or 7 classes of ships. Everything from small feeders, which would kind of go port to port, to ULVCs. And that's a clever name, which means, let's see, the ultra large vessel for containers, something like that. Anyway, some of the ships are actually too big to go through certain canals and into certain ports. The Suez Canal has specific depths, widths, and lengths. A lot of the ships are sized so they can go through these canals, but the mega ships these days carry up to 15,200 TEUs, and a TEU stands for 20-foot equivalent unit. So the 20-foot boxes, which is sort of the standard, big ships can hold 15,000 of them. So if there are 40 footers, it'd be about half that. And they're already designing new ships that will hold 22,000 TEUs, and they'll be up to 450 meters long. These things are gargantuan. And they're not free from disasters. You can see this guy had a little bit of a problem. I wonder how many dropped in. Looked like there was one here and one here. This is the Emma Maersk. You may have seen containers with this label on it. The Maersk is one of the biggest, I believe it's Dutch shipping companies in the world, And this one here is the Emma Maersk. There's several Maersks, and this is one of the largest. I think it's about 400 meters long. Huge ship. Okay, so what is a container? Well, all started back in the 30s. This guy named Malcolm McLean, he was a trucker, got tired of waiting in line to have his trucks loaded from the ships, and he came up with a patent on a basic box, which was this 20-foot container, and that became known as the TEU, the 20-foot equivalent unit that we just spoke of. And what he did is he gave this patent eventually to the shipping world, and now these things, as you can imagine, are made all over the world, all different kinds of factories, and you'll hear a lot ISO, which stands for International Standards Organization. And the basic standards are these 20-foot by 40-foot. They're about 8 feet wide, 8.5 feet tall, and 20 feet long. And then any combination, like a 40-footer, is obviously fits with two 20s. They also make 10-footers. You've got the 10s. You've actually got 53s now and 58s. You also have what they call high cube, which is 9.5 feet tall instead of 8.5 feet tall. You also have refrigerated containers. These are highly insulated containers that carry frozen foods and things like that. But the basic shape of them, basic construction, is a steel frame. It's actually the biggest chunk of it are the end pieces. That's a steel frame, and in this case it has the doors, and then there's another steel frame on this end, and then there's a steel tube which comes along and connects these two frames on the top and the bottom, and it's filled with this corrugated steel sidewall. So essentially, there you can see the front frame with the doors, and you can see sort of this beefier corner piece. This is how they stack up one on top of another. They also lock them together using a special lock thing that binds them together. And then you can see the bottom rail, which is actually up off of the ground. So this chunk here lifts it up slightly. And same thing with the top. There's actually a space between the two containers. And then the rear frame and the top cord. So essentially this forms like a truss, almost a bridge, because this thin, relatively thin corrugated sheet steel in the middle here, once it's cut, perforated, it doesn't have the same structural capabilities it does as a box. And you'll see when these things are stacked up, like behind here, they're always stacked up one directly on top of another. Okay, I happened to be traveling down the road and I saw this one here with all the specs on the back. This is called a high cube, so that means it's taller. It's 9.5 feet instead of 8.5 feet, sitting right on top of a tractor trailer. You can see the specs for this one. Overall length 53 feet, overall width 8 feet 6 and 0.36 inches, overall height 9 feet 6.5 inches. As I said, this is a 53. This is sort of a non-standard trailer. And obviously they fit right on top of trucks. Where I am in California, Port Hueneme is quite a large, busy shipping area, so we see a lot of this stuff going through. Okay, for container buildings, you'll see all kinds of shapes. We're going to talk about what they are, a little bit about the myth versus the fantasy. Cargo texture. There's a company up in Seattle, I think they may have coined that, I don't know, but I thought that was kind of cool. What works and what doesn't. And I'm going to show you a few cool homes. Okay, you will often see a lot of pictures like this with these, super cantilevered containers and very interesting looking designs. Of course, in construction, anything's possible, but if you were to build something like this, you'd have to do special reconstruction of the containers to get this kind of cantilever. You can't just stack them up naturally like that. You'll see a lot of very conceptual, high concept designs like this one here where they've got all these containers. You can see here this middle one looks like it has absolutely no structure at all in there. It's just all glass, right? Well, that'd be kind of challenging to build, particularly if you're in the Los Angeles or West Coast where we have earthquake issues. This one here is a very cool thing. Actually was in Santa Monica, not too far from me. I saw it, I don't know, 6 or 7 years ago. This architect here, Shigeru Ban, designed this, and it's called a Nomadic Museum. It's a museum that moves around the world for a photographic exhibit. And you'll see, interestingly, what he did here. You can see the container box right here skips one unit, and then the other one is here. So they're stacked corner to corner, but there's a void between each one. And this is actually a canvas roof in here between them. So when you're inside this building, it lets lots of light inside there. Really a cool thing. They kind of come in, set it up pretty quickly, and then I guess they pop it on a big container ship and send it off. I found this on the internet, CHK Catalog. They have virtually every kind of layout you could ever imagine. Again, here they show a lot of this cantilever kind of stuff, and we'll talk about how feasible that is. You will also see some not so inviting projects like this one. I think this is in Africa. This is some worker housing, and this guy here is guarding the housing and the lovely courtyard. Again, I think this one is in Dubai. They're looks a little depressing, doesn't it? But at least they have air conditioning. Okay, so container design. Now, simple is good with containers. This is a little hunting cabin. You can see they stacked three different, or put three different containers side by side next to each other on top of this raised platform, and then they built a roof on top of it. Now that's important because if you put three containers next to each other, the way the containers are made, the roofs on them shed water to the sides. They kind of have a little bit of arc, so they shed water to either side and down between the containers. So if you stack them together, you need to do something about the roof other than what exists with just the container. So here's one with a big roof, kind of a fairly simple type of design. I don't know if he's using that as a garage. It looks like he built on a little porch here. Probably an area where they didn't have too many building codes. You can see it looks like he's still figuring out what to do with this gap here. Looks like foam insulation. He's obviously cut some windows in here, smaller windows, and put the roof on. This is one I particularly like. As you can see, he put this, they call this hybrid, or a hybrid design, which means they used containers and conventional stick framing as well. So in this particular case, you've got two 20-foot boxes on either side, and then they added this roof structure which comes down here and kind of incorporates the two for a big volume room inside. You can see the guy and the dog right in there. So again, probably a non-permitted area. I like the way they lifted it up off the ground. This little chimney here, this is supposed to be 10 feet away from anything, so there's definitely a code issue there. And this one probably as far out as any I saw. This is in Korea. They call this the tea house. And I'm not even sure there's really any container left here, but you can see it's a fabulous steel structure, about 5 stories high. You can see all this cross bracing and steel beams stacked up. One side is just this kind of cool glass, almost meditation thing, and then I think the other side has a sort of a bedroom kitchen in it. So, as we say, anything is possible, but for most of us, for design and construction, using this kind of technology, using container homes, you got to think a lot about openings, because anytime you cut into these boxes, you are compromising the structural integrity. Typically, when you see, particularly if you see the entire side taken out, you have to reinforce that. Sometimes you'll see X bracing inside there. Sometimes you'll see some steel tubes which are attached in there to give this frame rigidity from the taking out the corrugated steel. And sometimes you will see actually a big steel beam underneath the thing to basically rebuild or resupport the opening. Insulation is another thing. Again, when you have these are just simple boxes, right? And they've got Corten metal, Corten steel corrugated siding. So a lot of times what's happening is guys will, and because there are particular characteristics for metal in terms of transferring heat and cold through them, and if you've ever been in one of these uninsulated ones like we use on construction sites during the summertime, you'll realize they are ovens. A lot of guys will spray foam right on the interior skin, and then they'll build a metal stud wall on the inside, and that stud wall gives you thickness for more insulation, also your wiring and piping and stuff like that. Also need to do the same thing on the roof, or if you are doing a roof over it, maybe you could do the insulation up there. We talked a little bit about the roof and the fact that these boxes are designed so that they shed water to either side. So if you're using more than one, you need to deal with the roof. Also, any kind of connection, particularly if you're going vertically, 2 is not so much of a problem, but if you get into a 3-story building, depending on your wind loads, snow loads, earthquake issues, other kind of structural things, you really need to have an engineer take a look at these things. A couple of basics. I created my own little container project here in SketchUp. Stacking containers this way doesn't really work. Again, that frame, that square frame that's on the end, is where the support is. So when you stack it this way, first of all, the lower one doesn't have any support. Remember, this frame you've got the little steel block on each end, and then this frame is a little bit lower, so there's virtually nothing below this point, and same thing up here. So you would probably have to reinforce these things to create some sort of a design like that. Also, the cantilever idea, again, there's no structural support here. We've got that gap that we're talking about. There's structural support here, but there's nothing that it's on. So when you see the cantilever stuff, it's quite a modified container. Same thing with this. This would be a 40-footer on top of 2 20-footers. You don't have any structural support here, so you'd have to retrofit your container somehow so that you got that kind of support. The good thing is it's not real complicated. These are rectangular boxes, and rectangles work well with construction of homes. If you cut out a window, a simple window in the frame, sometimes you can do that and it will work right inside the corrugated steel. Other times you will see bigger frames like this built into that steel tube frame that's already coming up across here, and this might all be glass. Sometimes you see the entire side taken out. Again, if they're stacked up, rectangle to rectangle, they're pretty good because they've got those blocks and they're meant to stack this way. But if you cantilever them or cross them, you're going to have to be doing some other types of structural reinforcement. Roof bow, we talked about that. This is how the roof bows. Basically these things are made as inexpensively as possible to hold the maximum amount of freight that they can. Once again, you can see there's the corner block that we spoke of and the corner frame that holds the doors. An easier way to deal with these things, although it may be a little bit more boring, is to simply stack them side by side, one double like this, one on top of the other, or some format like that. Now there are lots of homes where they have innovative uses. Like this one, it's 2 containers. You can see 2 containers here. And then the roof that is attached on top. So this has, actually it looks like there's a little house here too. So this is sort of probably an existing house that they built this all over. Here is a project that has 6 40-footers. 2, 4, and 6 up on top. This is in Georgia. You can see more from these guys, Runkle Consulting. I think they're building a bunch of these. You can see they have some cutouts and they have some reinforcement on the sides of these window openings here. One thing that's kind of neat, there's one particular project I like a lot where they took 2 20-footers and they simply set them not askew, but they set one back. And what they did in the design, I'll show you more when we get to it, is they created sort of a great room in the middle here, and then I think one area was a kitchen and one area was a bedroom. Certainly you can use one container and you can do all kinds of things. You can make a small studio, small office. You could add a roof over top of it, maybe a nice shed roof with some solar panels up there. You could do something like this one here, something like this Z shape here, quite easily. So for those small projects, quite a few people are building these sort of back in the woods, or for sort of second homes. This one, which I already showed you, which I particularly like, I'm curious how this roof was dealt with, because the snow drainage would slope back that way. Spoke about the chimney, but you know, pretty cool. I like the way they left the raw, kind of rusty old container as well. And this is that little L-shaped one that I showed you a second ago. These guys may have invented or coined the phrase cargo texture, but this is hybrid. This is hybrid architecture. If you want to check them out on the internet, architectural group out of Seattle, hybridarchitecture.com. And you can see in here, here's that great room we spoke of. Also, what I think is pretty cool is he put sort of a barn door railing, so he kept the corrugated siding, and this whole thing slides shut. So when they go away, this is in a remote location, so I guess when they go away, they can just shutter the whole thing down, lock it up, and it just looks like a couple of crappy containers. As I said, this one has these two containers in a design something like this, where the two are joined, and this becomes sort of the great room area. And then you have two little wings for, I think, kitchen and bedroom, something like that. This one here is in New Zealand, and it intrigues me because it's built into the hillside. In California, you'd have to do some major structural work here to build something like that. Obviously no windows. They didn't do much with these bottom two. I see one slice here. And then I kind of like this one. It looks like two containers width-wise, so 16 feet deep, more or less. And then, you know, it might be 220 or 140 footer. But I like the way it's built up on above the ground. So there's very little of this site that's disturbed. It looks like they've got some lawn chairs there for the hot summer sun. I believe this one is in Germany. And obviously this, you can see, has a big beefed up beam on this side because the whole side is all open glass doors. Now this project was completed by an architect named Walter Scott Perry. I just saw this at the Alt Build show in Santa Monica, which is always interesting, and he's been there a couple years talking about container design. And as a matter of fact, last year they were working on this as well. You can see their site right here. But they completed this one. They've had a lot of problems permitting these structures in Southern California, but they did this one out in the desert and had very good luck with permitting. And you can see it's actually, I think they used 6 containers here, and then they attached it. This is a sort of a prefab steel building out here. Obviously a container here, and a couple of containers here, and also here. But really a cool, very interesting modern home, I think. Lastly, this project in Venice, I think they call it the Frog. You can find out more about this one at demariadesign.com, architect in Southern California. This is their rendering, and actually this is another building that the same firm did in Redondo Beach. You can see they've got the containers right here inside a typically, I believe, a stick frame building. So it's sort of, again, a hybrid. They didn't make all containers, but somehow this container extends back in there. I'm not quite sure how it looks on the inside, but pretty cool nonetheless. Here is the actual Frog. So from rendering to reality. Unfortunately, I understand this building was foreclosed on. They probably started at pretty much the peak of the real estate market and were hurt by that, but it's an interesting example, and it's the only one I've seen in the LA area. You can count the number of containers here. We've got 1, 2, 3, 4, 5, 6, 7 containers deep by 3 levels high. So we've got, you can see some of the X bracing that's been done in here. Los Angeles is very difficult with structural requirements because we're in an earthquake zone. So here it is in construction. You can see they used a lot of steel to reinforce all those openings that they put in. There's some new walls on the inside. There's that X bracing again in the windows. You can see where they added big openings like this one. They added that tube steel that we were talking about, or additional framing where they took out the corrugated metal. And this I particularly like, the way they stuck all the door ends together. I guess they probably welded all this together, but they, you know, left the expression of all these. These are the handles. You've got two of these things which locks it up on the top and on the bottom and makes that gasketed rubber gasket seal up the end of the container. You can see those container blocks that we talked about. This is stacked. Each one is stacked vertically directly on top of the other, so there's good connection there. Another shot of that building. So containers and the Jeep, you know, really I think my point is they really are interesting. I own a couple of them. We use them on construction sites. I think they're great. I haven't built a home out of it, although I've considered doing a studio, and I want to do a more interesting job site office which has solar panels and stuff like that that we can carry from site to site, but still a work in progress. We talked about high concept versus basic concept, and obviously that one, like that one in Korea, there's some really high concept stuff going on. We talked a bit about codes and some of the challenges with building containers. We talked a lot about the structure, insulation, and how the roofs work. So I hope you've enjoyed this little brief primer about containers. And if you're not familiar with 50green.com, check us out. You can go to 50green.com/blog. We've got lots of free info. We also have a number of courses that we offer for sale at very reasonable prices, including the green building sessions, which is they're about 12-hour to hour-and-a-half long sessions, all in sort of video webinar kind of format. We've also got the Portland sessions, which tours a bunch of green buildings in Portland. Some very interesting stuff, a lot of passive house design, and then a real up-close look at the earthships, which are fascinating buildings. And if you're into green building, I suggest you look at all of these. We hope to see you more in the future, and thank you very much